So let us learn about Poynting theorem today. Vector product of electric field intensity and magnetic field intensity at any point is the measure of rate of flow of energy per unit area is called as the Poynting theorem. The direction of power flow is perpendicular to E and H in the direction of vector E cross H. So our Poynting theorem is this. P equal to E cross H watts per meter square. So to derive this, first we will take del cross E is equals to minus mu dH by dt, this as equation 1. Then del cross H is equals to sigma E plus E into del E by del T. This is equation 2. Now what we are going to do is, for this equation 2, multiply E on both the sides. So here for del cross H, I'm multiplying E, and for sigma E, I'm multiplying E, that becomes sigma E square. And for this equation, I'm multiplying E, that is E dot epsilon into d by dt. Okay, next we are applying vector identity. What is that vector identity in the sense? Now if you have del as E cross H, this can be written as E into del cross H minus H into del cross E. So this is the vector identity one. So I have written here that only del into E cross H is equals to del cross E into H minus E into del cross H. This thing will substitute in this equation, in equation 2. So instead of del cross H, I am writing it as H into del cross E minus E into del cross H is equal to sigma square in this equation, is equal to sigma E square plus E into epsilon dE by dt. Next, what are we doing here? Del cross E, substitute the first equation's value minus mu dH by dt here, minus E into del cross H is equal to sigma square E plus E into epsilon dE by dt. After writing this, what you have to do is, see, when you see this derivation directly at the first, you will not understand where what is happening. So I'm explaining each step clearly. I'm not reading the thing, okay? So here what is going to happen is, this thing, you keep it like that only. This you shift it to the right side. When you shift this to the right side, as it has negative sign, it will become positive. Here we'll have all three positive terms, but we want E in dot del cross H as positive. We'll take all these three terms as negative. This is what is happening here. Next, what you're doing, you're rearranging things. This thing you're writing it is equal to, okay, this is there, no? For this, we are changing that equation as this mu, you take it out, so it will become del H. This H will go inside dot H by dt, that is nothing but mu del H square. H dot H is H square by dt. This will be your equation 4. After getting your equation 4, next what we are doing is, this term is like that only, this term is like that only. Here what we are doing is, this you took it as outside, right? For this H dot H, we are splitting the terms. So H dou d by dou t into H, H dou d by dou t into H. So we're writing it 2 times. After that, you will get that as 2 mu H dou H by dou t. That will be your equation 5. 2 mu H dou H by dou t is equal to, this will become H square, right? This H you send it inside, it will become H square by dt. This 2 is there, no? You send it down. The dou by dou t mu H square by 2. After that, we'll take it as, in this equation, we have found the value for this. This will be like that only, there's no change. This we have to make some modifications that I'll show you in the next video. For that also, you have to modify it in the same way. Like as I said before, this E you're sending inside your dou, so it will become E square by 2. E square by 2. How did this by 2 come? After splitting that, you have to do same way like how you had done for mu H square by 2. Same process you repeat here, and you'll get this term. After you get that term, I showed you this equation, right? That is E into del cross H. Here you substitute whatever you have got, this mu H square by 2 and this E square by 2. After substituting, you'll get this equation. Now take dou by dou t, minus dou by dou t common, so you'll get plus inside minus dou E square. Next, take volume integral on both the sides. After taking volume integral on both the sides, apply divergence theorem and you'll get. Finally, after getting this, you don't stop it there. You have to write what is this. By Poynting theorem, we know that E into HDS will be our total power, and this will be a rate of decrease in energy stored in electric and magnetic fields. Decrease, why? Because we are getting negative sign here, and this is ohmic power. That is all for your Poynting theorem. The Poynting vector will be explained in the next video. Thanks for watching. If you like it, like, share and subscribe to Vlogs with Sanjay.